So welcome everyone. For today's lesson, we'll be doing all the questions that were asked on the WhatsApp group, and this is a question answer session. So some people have stated that this question is not clear enough. So I'm going to do question number one. If you have any questions, you can always post the questions on WhatsApp, but I will be doing the questions that were sent and asked for me to cover. So we're going to look at this question over here because a couple of students have asked me to show them step by step on how to solve this question. So this question I think is from the year 2020, 2022, if I'm not mistaken. Okay, so this question is from 2022. So let's solve this question. The question says that a 2 kilowatt kettle. Um, Sorry guys, let me just this really quick. Okay, so let's solve this problem. The given data is a 2 kilowatt kettle. So this is electrical power. Electrical power of how much? 2000 watts, right? We have an overall efficiency of 0.92. Mm, the mass is 1.25 kg. We have a temperature of T1 of 16 and T2 of 29. So we are heating the water inside a kettle from 16 degrees to 26 degrees. So let's read the question. A kettle, 2 kilowatts. A 2 kilowatt kettle with an efficiency of 92% is used to heat 1.25 kg of tap water at 16 degrees Celsius to 96 degrees. Determine the time taken to complete the heating. So, um, let's solve this question. Um, we know that Q is equal to M cat, and M is for the mass 1.25 kg. The CP of water is 4190, and the change in temperature is 96 minus 16, and we get energy which is 419 joules. Sorry, 419 kilojoules, right? This is energy, right? And we know that power is equal to energy over time. And we also know that power is equal to IV from the power triangle. So power triangle IV. And we also know that efficiency is equal to power output over power input, which is um, physical power over electrical power. Right? Um, so we use this value, use that one, use that one. So we have to remember the energy over here, and we need to, sorry, this here is energy, and this here is electrical power, and don't forget your efficiency over there. So what we're going to do there is calculate the energy of the kettle. Okay, so the energy of the kettle is equal to, so let's, okay, let's write power is equal to energy over time. No, no, wait, sorry, wrong formula. Going to start with this formula because of the efficiency. The efficiency is equal to power output over power input, and our input power is the electrical power, right? So we're going to find our output power. So our power out by the kettle is equal to the efficiency multiplied by power of electrical power. So it's going to be 0.92, which is 92%. We have to convert it to a fraction, and we get a 0.92 and then electrical power of 2000 watts. And the answer over there would be 1840 watts. So this is the power out, right? And over here is our energy out. And we know that power is equal to energy over time. So the first question asks determine the time taken to complete the heating. So to calculate the time, we're going to find the time here because we have the energy out and we have the power out. So time is equal to energy over power. So we have an energy of, see here, we have an energy of 419 triple zero over, okay, wait, 419 kilowatts, sorry, kilojoules over 1,84 kilojoules per second. Because we know that power is equal to energy over time, which is joules over second. So then these two are going to cancel and we're going to get an answer in seconds. So answer here is going to be in seconds. And we can see that when we punch this into our calculator, we get an answer of, just put this in my calculator quick, it's 419 over 1.8. So we get 240 seconds, and we're going to divide that by 60 seconds. So we get 3 minutes, right? 6, 12, 18. Yeah. we get 3 minutes and 50 seconds. So now the next question is calculate the cost. So how do we calculate the cost? We know that the cost is equal to energy Okay, let's plug in the values that are given. Um, where is this? Energy. So we want the cost, right? So we need to find energy, and the tariff is, I think it's 1,46 per kilowatt hours. So let's calculate the energy. So to get energy, so we know that power is equal to energy over time. So this is in joules, this is in seconds, this is in watts. So we want our answer to be power times time equals energy. So we want power to be in kilowatts and we want our time to be in hours. Therefore, we can get a energy of kilowatt hours. You guys understand how do we get the energy? That's how we get it. We manipulate this formula over here. And let's do that really quick. So we calculated the time for this question because that was the first question, the time. And we got 240 seconds. Sorry. So 2 kilowatts multiplied by 240 seconds. And we get an answer of calculator 2 2 times 240 2 times 240. We have 480 kilowatts a second. But we want to convert this to hours. So we're going to do kilowatts over seconds multiplied by 60 seconds over 1 minute. So we cancel, multiply again by 60 minutes or in 1 hour. So we're going to cancel those two and we're going to get an answer of so 480 multiplied by 60 multiplied by 60. Um, Hold on really quickly. Let me see if I'm not make a mistake anyway. 240 seconds, right? Oh, sorry, my mistake. It's kilowatts, not per second, multiplied seconds. So we have 480 kilowatt seconds, and we want kilowatt hours. So then we're going to multiply by 1 minute is 60 seconds, and we're going to cancel them out, seconds and seconds. Then again, we're going to multiply by 1 hour is 60 minutes, and we're going to cancel again. I hope you guys remember this from fluid dynamics, also called dimension analysis, and we're going to get an answer of, let's do that in our calculator, 480 multiplied by, divided by 60, 60 divided by 60. So we get 130 times 10 to the minus 3 kilowatt hours. So we're going to take that value and multiply it by the tariff. So to get the cost, you're going to 130 or 0,310 multiplied by 1,5 rand. Okay, wait, let me put the units in. Kilowatt hours multiplied by the cost of 150 kilowatt hours. Cancel those two, and then you get an answer of multiplied by 1.5, and we get 200 times 10 to the minus 3, and that's how much it's going to cost. Let's check the memo. So in the memo, so over here we have three decimal places, 1, 2, 3. Our answer here is rand is equal to 0,2 cents. And in the memo, they have a rand value of 0,18. But that, of course, is because rounding off. Are there any questions? Yes, sir, Mr. Yes, your hand is raised. You can just ask the question. So, how did you get to 260? Is that your question? Your hand is raised. I can't hear you. Oh, turn 227,71. What value is that? Yes. So how did you get 260? I got 227, 260, 260. What are you talking about? This? Oh, this is 240 seconds. If you're not getting the same answer, it's because I rounded off. So also here at the end, you can see I got 20 cents, and the memo is 18 cents. So it's just the fact of rounding off. But I think you should be very close to the actual answer in exams. But just for this tutorial, I did rounding off. So it's actually 240 over here. I think 360 seconds is going to be 3 minutes or something like that. Yes, sir, your hand is still raised. Do you have a question? Can I go this and okay, so let's move on to the next question. So someone asked in the group, let's check what did he ask. Um, what did he ask in the groups? Okay, so this question here, let's copy this one. Let's go to, sorry. Solve this question for you guys. Add a new page. So this was the question that he asked, and I think it's from which year is this one? Is it 2021? Let's see. Twenty 22. No, 2023. 2023. 2021. Sorry about that, guys. I'm just looking for where is this question from. Okay, let me solve it. Oh, someone says 2020. Cool. Let me just look in the question paper. 2020. So the question says that what is pumped at a height to 150 meters at the rate of 200 liters per minute. The efficiency of the pump is 200 volts. Power of the motor or okay, so we have two efficiencies and we have this is the volumetric flow and This here is the height. Okay. Okay. So in fluid dynamics, okay, let's talk about electrical power. Electrical power is equal to IV, that is your electrical power triangle, and power, fluid power from fluid dynamics is equal to rho G H Q. And we know Q and rho is equal to mass flow rate. So this is volumetric flow rate, this is mass flow rate, G and H. So now to solve for power out, because we know that efficiency is equal to power out over power in, which is the electrical power. So to solve this equation, we are going to then convert this liters per minute to seconds. So we have 200 liters per minute multiplied by 1 minute is 60 seconds. So that cancels, and we have 200. So m is equal to 200 over 60 liters per second. Okay. So now we get our power out, which is equal to mgh, and m is equal to 200 over 60 multiplied by 9,81 multiplied by 150 meters. Now answer there is 4905 watts. Is everyone getting the same answer? Let's just double check this. 200 divided by 60 to convert to seconds multiplied by 9.81 multiplied by 150, and we get an answer of, okay, so this is correct. Um, one more thing, and that is, yeah, that is correct. So we have our power out. Looking at the question, we have two efficiencies. So we know that the overall efficiency, we know that the overall efficiency is equal to efficiency 1 multiplied by efficiency 2. So we're going to multiply 0.73 by 0.82. So then our overall efficiency is going to be 0.72 multiplied by 0.82. So we have an overall efficiency of 0.59. That is our overall efficiency, and we know that efficiency is equal to power out over power in, and power in is the electrical power. So let's go back to the question. So let's not forget the power. They're asking for the current of the motor. To get the current, we're going to use the electrical power, and we need to find the electric power, and our electrical power is going to be power in, which is electrical, is equal to power out over the overall efficiency. So power out is equal to our 4905 watts over overall efficiency of 0.5, which I calculate this 0.59, and we get the power in of 8194 watts. That is our input power. So we use the power triangle P over IV. So electrical power is equal to current voltage. So our current is going to equal to electrical power over the voltage. And our electrical power is 8194 watts over the voltage is 200 volts. So we're going to divide this by 200 and we're going to get a current of 40 amps. Okay. Are there any questions? I see that your hand is still up. I'm not sure if that's a mistake, but let's carry on with the question. The next question is going to be the cost to run the motor for 24 hours, and it's only 2 marks, so it's probably just one formula, and they give us the cost. So the tariff is, let's write this, the tariff is equal to 0.35 cents per 1 kilowatt an hour. So they give us a time here. Our time is 14 hours. So we don't have to convert or anything. So for question B, we know that power is equal to energy over time. And power is normally in watts, and here is joules, and here is seconds. So energy, we want energy to be power multiplied by time. We want our power to be in kilowatts and our time to be in hours. Therefore, we can get kilowatt hours. So our electrical power is 8,194. So we're going to convert that to 8,19 kilowatts multiplied by 14 hours a day, and we get an answer of, our answer here is going to be 114 kilowatt hours. That is our energy, total energy. So now calculating the cost. The cost is going to equal to total energy is equal to, no, total energy multiplied by the tariff. So then total energy is equal to 114 kilowatt hours multiplied by the tariff, which is 0.35 cents. 0.35 cents over per 1 kilowatt hour, and then these units cancel, and we get a cost in rands of 40 rand per day, because we have days of the year. um, Day per day. So that is the cost. Is there any question for this problem? So there are no questions. Let's move on to the next problem that someone asked in the group. Someone asked another questions. So question number 3. Does anyone know from which question paper is this question from? Okay, sir, your hand is up. Do you still have a question? No questions. Mm, so I see that this question is from 20, 2023. So I think I did this question last year. Ish. Let's go to the whiteboard and see if we can solve this question. Let me copy this. Copy. Okay, so the question says that a DC generator having an EMF of 150 volts, an internal resistance of 0.25 is connected in parallel with a battery of EMF of 80 watts and an internal resistance of 0.6 ohms. The combination is used to supply a load having a resistance of 5 ohms. Draw a circuit diagram and use Kirchhoff's law to determine the value and direction of the current through the battery. Cool. So let's draw the diagram. Shouldn't be that difficult. We have a voltage of 150 and an internal resistance of 0.25 ohms, 150 volts, and then it says it's connected in parallel with a battery of 80 watts. So let's draw parallel 80 watts, parallel 80 watts, and an internal resistance of 0.6 ohms. So internal resistance 0.6 ohms, 180 watts. The combination is used to supply, so also in parallel, because they're both supplying a load having a resistance of 5 ohms. So we have another load here. So this is our load, which has a resistance of 5 ohms. This is our load. So the first question is 3.1, current through the battery. Okay, the current through the generator. So let's label these diagrams. DC generator. Okay, so this here is our generator and this here is our battery. So we know that I1 flows here, that's I1. I2 is over here going down, and I3 is over here going this side, right? Mm, I3. Sorry, this is 80 watts. This here is 80 watts. So therefore this is the bigger one and that's a smaller one. So then this has to change into a supplied I3 is equal to I1 plus I2. Okay, so how are we going to solve this question? So it's basically doing Kirchhoff's law. So we're going to break it into steps. So the first step, redraw the diagram. Redraw this diagram. Okay, you don't have to redraw it, but I like to redraw it because that's the method I use, and it takes quite a little time, but you understand better and hopefully get a mark for drawing those diagrams. And let's start with the first one, and the first one is going to be space. Let's say the existing. I'm trying to get both of them in one space so you guys can understand. So let's redraw the diagram and follow the circuit, get equations, and we should be done and on our way. So we have 150 volts here. We have an internal resistance of 0.2 ohms. It travels right around the circuit. Our load has 5 ohms, and then it closes over there. So now we are going to focus on this circuit itself. This here has a current of I1, and this has a current of I1 plus I2. Um, let's do the maths. So we know that's conservation of energy. Sum of the voltage should equal to sum of the voltage. Our voltage here is 150 volts, and our voltage here should be I1 multiplied by the internal resistance of 0.25, right? So what are we doing? Sum of the voltage equals sum of the voltage. And we know from Ohm's law that voltage is equal to I multiplied by the resistance. So we are going to multiply I and the resistance to get the voltage from Ohm's law. So now let's do that by 0.25 ohms multiplied by the current of 1 amp. Moving to the next, we have to go right around, but remember it's parallel over here, and this is I1 and I2, so the voltage over here is going to be um, 5 I1 plus I2. If this confuses, another method you can use is this is assumed to be series, so we're saying that total voltage in series is equal to the sum of the voltage, which is V1 plus V2. And V is equal to I times R. So that's what we did here, R times I. Same thing. So now we have equation number one. Let's crop this out here. Smaller square. This is equation number one. Equation number one. Let's move this on to the next slide. Let's focus on the next equation. So now we're going to focus on the second branch. So we have 80 watts here, internal resistance of 0.6, and a load of 5 ohms. And we know that the current here is I2. Let's erase this. 80 watts, and the current here is I2. Current here is I1 plus I2. And this is 5 ohms, and this is 0.6. So now we have to get sum of the voltage equal to the sum of the voltage. And we have 80 volts here. Then we have 0.6 multiplied by I2 plus on the other side we have 5 I1 plus I2. So let's copy this onto the other side, and this will be our equation number 2. This is equation number 2. So that is our two equations. So let's copy it, paste it over here. You'll notice this thing. So we have an I1 over here and an I1 over here. and we have an I2 here and an I2 here. So let's do the mathematics and get simplified equations. So our simplified equations is going to be 150 is equal to 5 comma 2 5 I1 plus 5 I2. So now this is equation number 3. And on the other side, when we simplify, we get 80 is equal to 5 I1 plus 5 comma 6 I2. This is going to be equation number 4. Easy peasy, right? So now, what does the question say? Let's go back to the question. The value and direction of the current through battery and the value and direction of the current through the generator. So the generator is I1 and the battery is I2. So basically they want us to find I1 and I2. And how are we going to find it? You are going to make a lump. Sorry, this is not like simultaneous equation. There's a little bit different. So what you're going to do is you have to eliminate one of them. So which one do you want me to eliminate? Do you want me to eliminate I1 or do you want me to eliminate I2? You guys still here? You didn't. How should I2. So someone says they want to eliminate I2. Okay, so to eliminate one of them, there's the faster, harder method, and there's the easy, much doable method. So I'm going to do the easy method, and hopefully you guys can understand the easy method and not the difficult method. So someone said the session is recorded, but it's going to take me time to upload it, and I'm not sure if you guys can have it by. Okay, I'll try my best to get it between before 8 o'clock. Let me just see. Someone says I should eliminate I2. So I'm going to show you guys the harder method, but it'll help a lot. There's obviously a faster method, and the sessions will be uploaded. Probably I'll try my best to get it by 8 o'clock. But without wasting time, let's finish this. Hopefully, I want to be done before 5. So, someone said, let's get rid of I2. So to do that, the hard method, which I like, which is boring, you see that this one is 5 comma 6 and this one is 5. So we need to create a likeness between them. So what I like to do is I'm going to multiply this with 5. I'm going to multiply this by 5 comma 6. You're going to see that in a moment. So now let's see what we get. Calculator. My calculator broke, so I'm using the calculator on my cell phone. Um, so we're going to start from that side. 150 multiplied by 5.6, and we get 840 equal to 5.25 multiplied by 5.6, and we get an answer of 29 I1, and then 5 times 5.6, and we get plus 28 I2. So let's now move on to the next one, and we're going to have sorry 80 multiplied by 5, so we have 400 is equal to 5 times 5, which is 25 I1, and then we have 5.6 multiplied by 5, and we have positive 28 I2. Now, what we're going to do is we're going to subtract. So the person that asked this question, mm, Guana. Okay, so basically what we're going to do is subtraction, subtraction. So we're going to subtract the 2. So 840 minus 400. We have an answer of 440. And then we do it again with the next values, which is 29 minus 25. And we get an answer of 4I1. And then we do it on the other side. 28 minus 28, we have 0. And we can use this now to solve for I1. So 440 equals to 4I1. We can see that I1 is equal to 440 over 4. So I1 is equal to 440 divided by 4. So we're getting I1 is 110 amps. Let's look at the memo. The memo says I1 is equal to 100 amps. So we made a mistake somewhere. Mistake. See, 5,2, 5 multiplied by 5, 80, 5, 5,6, 5,25, 5, 150, and 80. 150 and 80. Let's try that again. Let's do it again. Um, 150 times 5.6. That's 840. 80 multiplied by 5 equals 400. Okay, 5 times 5 is 25. That should be 28. So let's see, 5.52 multiplied by 5.6. Okay, so this one actually is supposed to be 31. So let's do that again. Let's go down. So we have 6. So then we're going to divide by 6. So 440 divided by 6 is equal to 73 amps. And we look at our memo and we see 75. What?
Sorry.
Just hold on, guys. Let me just see here. 5.25 multiplied by 5.6. This is 5.25 is equal to 29, right? 29 minus 25 is equal to 4. 414, 4.
What is the final answer?
I'm just seeing if there's a mistake here. So 400 and then 5 times 5 is 25. Okay, so I'm getting 110 amps, but in the memo they got the 100 amps.
It's 29.4, not 29.
29.4 over here.
Yes.
Okay, because I'm using my phone as a calculator instead of so let's see now. 29.4. So okay, so they got 4,4 I1. 4,4, okay, it makes sense. And now we have an 100. So 440 divided by 4.4, and we have 100 amps. Okay, thank you. Okay, I can't see your name, but thank you for that. I don't know what happened to my calculator, so I'm just using the ones on my phone. It's quite challenging now to actually, Anyways, back to the question is that they wanted, so that would be I1 through the generator. So I2, to calculate I2, you can just substitute into any of these formulas. So we can say that 150 equals to 5,25 I1 plus 5 I2 plus 5 I2. So we have this, we have to find this one. So let's do 150 minus 5,25 100 equal to 5 I2. So we divide this by 5 and I2 will equal to answer over 5. Let's see that. 150 minus 5.25 multiplied by 100 divided by 5. So we get negative 75 amps. And the answer is negative 75 amps. Okay, so you guys, hopefully you guys understand how to solve these equations with two unknowns. Okay, sorry guys. Someone asked me, are batteries included in tomorrow's question paper? Batteries. Yeah, in circuits we are working with DC, so most definitely those are your batteries. Okay, so 29.4. Okay, thank you. Okay, thank you, thank you. You see, I was working on the calculator and seeing I could fix it. Haven't checked the messages. Um, let's see what's the final question. The potential difference across the load. So they want us to calculate the potential difference across the load. Um, so basically they want us to calculate the potential difference across the load. And to get the potential difference, we know that 5 I1, sorry, Ohm's law, voltage is equal to current times resistor. So they want the potential difference, and we're going to then have to just 5 I1 plus I2, which is, I think I1 is 100 and this one is negative 75. So we get a potential difference of, calculator, 5 multiplied by 100 minus 75, and we get a potential difference of 120 volts. Let's check the memo. The memo has 125 volts. Okay, let's see calculations. 5. Okay, I'm still getting 120. Oh, I said it's 125. Okay, so apparently they did it the other way. They used the second equation, which is 80 is equal to 5I1 plus 5,6I2. So basically they use this equation, if I'm not mistaken, voltage for load. Voltage for the, what is the question? The potential difference across the load. This is the equation for potential difference across the load. So they used 25 times 5. Five. Um, Guys, I don't know how, but this calculator that I'm using, because I know that this is going to be 25. So if 5 times 25 is 120. What does the memo say? Okay, so I think the memo is wrong because the answer should be 120. Wait, no, it's this calculator. Sure. 5 times 20 is 100. 2, 4, 6, 18. 6, 18. 5 times 20 is 100. So 5 times 25 is 125. Um, yeah, it's the calculator I'm using. Sorry about that. So the correct answer is 125. Thank you for joining the class, guys. If there's any questions, don't you can just ask them. Do you guys have any questions? No questions. I think that should be the end of the lessons. Thank you for joining, and I will post the recording on Blackboard. I mean, not Blackboard, sorry. I'll post it on the YouTube probably.